Make a short video here. This is the Unit 5 summative review. I'm going to have this video cover problems 1, 2, and 3, which is the front side of that summative review page. All right, now on problems numbers 1 and 2, they've given us a table. So here we're looking at problem number 1. They've given us a table, and they're saying, hey, can you look at this table right here, and can you now write the equation and then draw us some type of graph? All right, so let's get to work on this. So as we look at this table, the first thing my eyes always go to is the starting value, in this case, 0, 4. All right, let's go ahead and plot that. 1, 2, 3, 4. All right, 0, 4. We've got our starting value. Now, what is happening to that starting value? As we progress down, we're going up by 1 on the inputs. Then the outputs looks to me like it's going from 4 to 6. It looks like it's adding 2. Now, we have to check that. You can't just say, oh, I know it's adding 2. Is it continuing that pattern of adding 2 and adding 2? Now, when we see repeated addition, that's indicative of the fact that we are dealing with a linear function, all right? If you see that repeated addition, in this case, it's adding 2, so it's increasing every time we go down the table. Now, don't forget, if we go backwards, are we doing the opposite? Subtracting 2, subtracting 2, yep, it works out. Perfect. All right, now we need to go ahead and plot the rest of these points. So we get 1, 6, 2, 3, 4, 5, 6, and then I can do 2, 8. That's going to be up here, and 3, 10 is going to be up here. We can plot all these points if you want to. We can plot as many as we want until you get comfortable enough that you can say, hey, you know what? I'm ready to draw the line through these points. Sorry, it's not perfect. And we could verify that we have a slope of 2 here. Pick any 2 points and say, yep, to get from one to the other, I have to go up 2 and to the right 1, so I know I have a slope of 2. So when it comes to writing this function, it's going to be y equals, what's my slope again? I can look to the table and say, yep, as I was going down, I was going up 2. Every time I was going up 1 over here, so that's a slope of 2 over 1, or just 2. Remember that goes or precedes with a coefficient to x. And then what was my starting value again? Oh yeah, it was at 4, right? Don't forget, that was given to us in the table. So my starting value is going to be then plus 4, and that would be my function. So number 1, again, you could plot every point and draw the line first, but sooner or later you need to figure out what that slope is and what your y-intercept is so you can write the function. Moving on to number 2. Again, given a table, so I focus on that starting point of 0, 4. I know that's in the table right here. The question is, what's happening to that point? I always like to start kind of in the middle at that starting value and then ask myself, all right, what's going on here? How am I getting from 4 to 8 and from 8 to 16 and from 16 to 32? It becomes pretty clear I'm not adding, because if I were adding, it'd be the same amount every time, but that's not happening. I am multiplying by 2 every time. So I know that if I'm multiplying by 2, then this thing must be going up or increasing, because when you multiply by 2, values as they get larger and you multiply by 2, they get even larger, correct? So I have an exponential relationship based on multiplication, and it's going to be increasing. Now, plot a few more of these points over here. 1, 8. All right. Negative 1, 2. Negative 2, 1. Negative 3, 1.5. You'll start to see this graph develop. Now, don't forget, as you graph these, it's going to hug that x-axis, and then it's going to exponentially, it should be a nice smooth curve. Do not draw a line through this. This is not linear. Now we got to write the function. Remember our functions, exponential functions. You always start with your starting value. So in this case, we started out at 0, 4, so that's going to go first. Then in parentheses, we always have something in parentheses to a power of x. That's going to be our multiplier. In this case, we are multiplying by 2, so that should be pretty straightforward. Again, if this number inside the parentheses is bigger than 1, then we have an increasing function. If the number in those parentheses, that multiplier is between 0 and 1, it's a fraction, like 1/2 or 1/3, that's when we're dealing with decay or decreasing. Finally, problem number 3 for this video. We are not given the table. Notice that we are given the function right here. Now, what kind of function are we dealing with? That should be pretty obvious right out of the gate, that it is exponential. And what did we just talk about? What are we multiplying by every time? We're multiplying by 1/3. Now, you may not know this right now, but that is indicative that this is going to be decreasing. But we'll come back to that in a minute. Now, What value are we starting with? Well, when you look at an exponential function, that number out in front, in this case the 6, that is our starting value, so 0, 6. Now the 1/3 tells me what my multiplier is. That tells me every step along the way I am multiplying by 1/3. So we go ahead, we can fill this in. 6 times 1/3. 6 times 1/3 is 2. 2 times 1/3 is actually 2/3. I do not want decimals here. 2 times 1/3 is 2/3. 2/3 times 1/3. Remember, you multiply straight across. So 2 times 1 is 2, and 3 times 3 is 9. So you get 2 9ths. Now here's the kicker. How do you go backwards? How do you, if you're multiplying to go forwards, you're going to divide to go backwards, right? Well, dividing by 1/3. We already talked about this once in the other note sheet, other note video. Dividing by third is the same as multiplying by 3, right? What is the reciprocal of 1/3? That'd be 3 over 1. So if you want to multiply or divide by 1/3, that's multiplying by 3. So as we go backwards, we're simply multiplying by 3. So 3 times 6, 18. 3 times 18 is 54. And 3 times 54 is actually 162. Now, as we go down, and I'm going to erase this, so I'll write over the top of it. As I go down, am I consistently dividing by 3 if I were to go back to the top and go, yes. That means if I'm going backwards, I should be multiplying by 3. It worked out just perfectly. Now, let's go and plot a few of these points. 0, 6, 1, 2, 3, 4, 5, 6. 1, 2. 2 2/3. As you can see, this thing drops pretty quick. Negative 1/18 is not even going to be on the graph. I mean, 3 and 2 9ths is going to be way down here. And as you can see, this graph is curving, plateauing here and going up this way, right? I'm trying to draw a nice smooth curve here. Wasn't too successful. All right. So is it clear to everybody out there that after seeing this graph that this thing is decreasing? It's going down. So that would verify our initial instincts there about this being a decreasing function. All right, take your time, rewind, look back, listen, try it again. But hopefully this video is a benefit to you.